I split this video from what I had planned. The video is too long and I'm too far behind due to my winter voice issues. I became interested in the 20mm version of the 6.0 heads because my rebuild engine utilized the service version. During my career working for a company that supplied OE parts to many brands, including Ford, a few times we had TSBs and unfortunately one recall. Risk management lawyers always well-crafted the documentation. Ford announced in January 2006 changes to the manufacturing process of the 6-liter engines to facilitate the upcoming 6.4-liter engines. Really? It's just a tooling change. I see this as a diversion. Between the engines, the camshaft and the head bolting pattern is the same, but that's about it. They flipped the larger countersink into the CNC for boring the locating dowels in the block, but everything else in the early to late 6.0 blocks is interchangeable. The 6.0 to 6.4 block castings are similar in design, but they are not the same. The document notes the changes are to the head gasket, rocker arm carrier, which is the rocker box, and the injector hold-down clamps. None of those are common to the 6.4-liter, and that's a lot of retooling. The new 20mm cylinder heads have several casting changes, and the injector clamp bolt position has been moved. So it's a new cylinder head design, and they even say that. It's not at all like the 6.4 cylinder head, and not a simple change in the manufacturing process. And to make these changes is costly. With my supplier company experience, we started developing a product 2 years before model year launch. Other items, and certainly engines, would require longer. It would take us about a year to prove out replacing an existing manufacturer's part. So this had to be conceived well before 2006. A different cylinder head, probably requiring rerunning many tests and possibly emissions. A head casting change would not have been a job taken lightly. So why do this? From my experience, Ford gets real hyper when warranty crosses 3%. Real hyper. In a 1% warranty range, we would have to report our QC data to Ford. At 3%, they would have been in our plants to review everything: quality control, process, and engineering. Most people believe Ford engineering designs everything, but depending on the product, the supplier can do 99% of the engineering. Ford just gives them the envelope. That's true of this motor. Until there is a major issue, and then Ford will help you out while you're kicking and screaming, or they are finding a new supplier. That's hard to do with an engine. A newly reported lawsuit against Ford by an angry 6.0 owner might shed a glimpse. We knew about the lawsuit between Navistar and Ford around the same time. The warranty was huge. Injectors, turbos, and the peak combustion pressure exceeded their normal parameters from what's read out of the lawsuit. I see those risk management seminars kicking in, especially when it's said to delete emails. But apparently they didn't. But we don't know where this manager came from in his new position. I tried to find him on LinkedIn, nothing there. If it was from the gas engine side, those peak cylinder pressures are much lower than what he would have experienced, and he would have freaked. Most people don't know the warranty gets charged back to the supplier, almost all the costs. But Ford is also concerned about the perception of Ford products. As many of us are aware, a few heads crack at the injector bore, typically at injector 5 or 7, allowing fuel into the coolant. That's not a significant occurrence compared to other failures, but they included a change in this head to address it. The International and Ford cross lawsuits at this time frame may have focused on a new head design. While the F-Series was about to get a new engine, the vans would continue with the 6.0 until 2010. And no one wants to change head gaskets in a van. Reinforcing and moving the injector clamp hole indicates the bolt's tension might be involved in the crack formation. A higher torque than specified has its risks. But this change also has a higher tensioning of the bolt. That may be because the injectors required it, or a change in the leverage of the hold-down clamps required it. I don't have the two different clamps to compare. Another part of the announcement was that a new kit would be available, so the new 20mm heads would replace older 18mm heads, as they were being phased out. Despite an earlier comment leading you in the direction of a process change, I see this as a design change to address failures, as this is a lot of work for just the rare injector bore cracks. A few months later, another publication tells the head differences, since now we are going to interchange using the step dowels to the older blocks. There actually were 4 different 18mm head castings. Those appear to be minor changes as they use the suffix. It's similar to the Ford parts number identification. Ford uses the suffix to denote minor changes. The Ford prefix will show a significant design change, typically with an updated year designation. Navistar updates the initial numbers. The pages from the Navistar manual for 2004 to 2006 do not show 2003 model year version. They only show the 3 modifications, C2, C3, and C4. The rocker carrier bolts are an apparent change mid-year 2005, reducing from 8 down to 2. That could be as simple as a cost savings measure. During the mid-2006 model year change with the 20mm heads, the 2 bolts change positions and the hold-down clamp changes. Another view, you can pause the video to read it. I wish we knew the details of all the changes before the redesigned 20mm heads. There is another change, 20mm service replacement heads, stopping the production of the 18mm heads. The same 20mm casting number is machined for the 8 and 10mm rocker carrier bolting variations, and also uses the earlier design hold-down clamps. These are the heads that I have. This brings up the question about what torque values to use, and if the offset to the post alters the strength. You could see the offset with my heads, how the hole is positioned in the cast post. There's no documentation of what the proper hold-down torque should be with these heads. It may be critical to know. The other characteristic to note is that 20mm heads have a changed core plug size. The 18mm heads use a 28mm core plug, and the 20mm or commonized heads use a 32mm core plug. Commonly called freeze plugs, while they may pop out under freezing conditions, that is not their purpose. They are core plugs. The easiest way to check if you have 20mm heads is by measuring the core plugs. The one attached at the front of the passenger's head, or you can also check the driver's head in front of the exhaust manifold. In service, an engine may have one 18mm head and one 20mm head. If you are not familiar with casting, the change in size may not mean much. I had the luxury of some schooling on the subject of casting. In school, and during the first 5 years of working for my long career company. Other divisions of the company were involved in metal casting, and we had the experimental foundry right next door, which I visited as I had time to. And my brother-in-law used to be a pattern maker for casting molds. Heads are one of the most complex casting situations. You have separate cores for intake ports, exhaust ports, and the coolant passages. The core end supports are named core prints. These hold the cores in place to prevent them from shifting. For intake and exhaust ports, that's easy due to the size of the openings for the manifolds and valves. Besides where the core plugs are, the coolant core also uses support members that become the ports for the coolant flow from the block to the heads. These core prints are important to keep the core from shifting due to molten iron's energy or weight flowing through the mold. If you need more stability because the cores are shifting, you increase the size of the print, and then you need a larger core plug, or freeze plug if you want to call it that. I'll throw in some color images so you can see the complexity of the Swiss cheese. That type of core shifting may be part of the issue at the wall of the injector bore noted earlier, and it may be an issue in the thickness and stability of the head's bed plate. This is the section known as the bed plate of the head casting. It's key to how well the head remains stable in use, and its ability to resist flexing is critical. I'm hoping they did more changes than just about the injector bore, but you wouldn't know it unless you sliced up existing heads and compare the 18mm to the 20mm. And we have evidence our heads flex. It's most prevalent when you think in terms of a span between anchors, as we have with the 6.0 heads bolting pattern. In Kill Devil's description of their head castings, they talk about having a thicker area in the head, and I'm speculating it might be the same with the 20mm heads in comparison to the 18mm. It would only make sense to me. A redesign of this head would be the time to address many issues. When I mapped out my 20mm heads, there was tenting in the center. It shows flexing. But this was reasonable and addressed easily with my lapping method. I was able to flatten the head in width without the typical milling, which would have brought me under the 3.74 target for thickness. I went through all the vehicles in my 2003 service manual. There are only 2 engines where something is mentioned about machining the heads. One says it's not advised. The other is the 6.0. Emphatically stating not to mill or machine. If International was having an issue of core shift or just a poor design, they would know that at the worst case situation, milling might cause a worse issue. So you would give a minimum, just like we do with brake rotors. But like brake rotors, sometimes there's a core shift. You have a minimum, and sometimes you have a little left over. But you always designate the minimum. Of course, my lapping would not take care of any stress cupping of the heads. Heads that cup or change their flatness days, months, or years after being machined is not a new situation. Historically, heads have done this as well as other cast products. It's not a result of poor machining practice or milling setup at the time of manufacture, as some may think. Often it's a function of residual stress, how long the parts are in the sand mold, which alters the crystalline structure of the metal. The decision is based on the properties you want the item to have. But as this SAE presentation notes, a long shakeout time can minimize residual stress that leads to warping, but other issues come up. There's no free lunch. The issue is also known as creep strain. It has variables which will alter how long of a time it may take to move and how much it may move. Is it occurring a week after machining, a month, or a year? Are we bolting up the heads in the primary stage or the secondary stage? Is it time, heat, or combustion pressure altered? Where are we at any given point in this curve? I know racers who only use seasoned blocks and heads just for this reason. Notice also on this brand new head being machined that the valve seats are induction hardened. This also leaves stresses in the casting, which is why we have cracks. Several forums and sites have documented the stress cupping of these heads, including brand new heads from Ford. With this example of a new head, since we can see the heat coloration from the valve induction hardening, we know in production they are surfaced and then hardened. The head is being resurfaced because the person is concerned about the bow. During the early stages of working on my heads, I did an elevation check with my straight edge and feeler gauges. This is not as good as using a granite block or working with a 3-axis measurement device, but it gets you in the ballpark. The original standard from both International and Ford was no more than 0.004 of an inch deviation across the length. And that is also the standard used for most heads, which would be 1/1000 every 6 inches. Felpro and Molly mention the same in their videos and literature, as does most service training. You could see my head cupping is in the same manner as the new head example. As I've mentioned before, in Ford and International's updated head flatness specification, they say to disregard the bow as it will flatten out when tightened down. I'm going to accept that answer with the belief they have done a lot of homework, as I know they do from my work experience. Ford reduced the allowed value across the width of the head, and that is more than one might realize once you start looking at the possible variations of the old spec as it relates to waviness. In my viewpoint, it's still too generous and probably what has led to so many reworked heads in the dealership environment to fail again. That and the stringent control of inadequate cleaning. Vehicle owners using tunes didn't help. At 75,000 miles, these heads show a profile that they moved in the center and in the combustion areas. And down the center line is where the head gaskets typically fail. This is plastic deformation. The areas under the head bolts stand proud in a taller plane. Because I'm dealing with an example of one, there's no way to tell if these 20mm heads are better or the same as 18mm heads for the same service experience. I have never run a tune. I would expect the head would have stayed flat across the width if there was less of a span between the bolts. A higher clamping force at the anchors, the fastening points, is not going to change this. Only reducing the span or strengthening the head would. As Molly's pictograph shows, the span matters. You have less contact force or clamping force in the center and always will due to the span between the bolts. The wider the span, the less clamping force transmitted in between. While you can increase the clamping force, it's always proportional. And with less clamping force in this area away from the bolts, the head gaskets tend to move in reaction to the peak combustion pressures. This will abrade the gasket sealing compound at the block deck and head, more so with a rougher surface finish, and this is why MLS gaskets require a smooth finish. This is not so much of a head bolt stretching issue, not that head bolts can't stretch. When 6.0s have a loss of coolant, like every other gas or diesel engine, the head's overheat expansion can induce failures in several ways and stretch the bolts. But that's in the next video. All of the things I'm seeing and hoping for with these 20mm heads may be incorporated into what Kill Devil does with its heads, grabbing the literature that Kill Devil says about their heads. A higher nickel content, a thicker surface plate for more rigid casting, more material around the injector bores, and reinforcing the injector bore holes, the post. If I was not able to massage my existing heads into compliance, had 18mm heads, was going to expect a long life from this truck, and had the money, those heads are the ones I would be buying. And if I couldn't spend that amount of money, I would buy 20mm heads from Ford and take the chance. And without spare heads to cut apart, there's no way to confirm any bed plate changes between the 18mm and 20mm head design. I know my old company and Ford would have done that with core and warranty returns to find the failures. I really hope these 20mm heads have all that. Thanks for watching.
Brother, there's too many of you crying.